Okay, today I'm doing one on keying circuits. How I test keying circuits and amplifiers with low power, and before I put it all amp all back together in this case, and get everything hooked up, and then find out that the keying circuit doesn't work. So, when I'm going through an amp, whether it's one like on a board like this or, point to point wiring or whatever, I like to test the keying circuit before I put it all back together. And since this is the latest project I have on the bench and I am testing it now, I'm going to do this video to show how I do it on low power, safely without plugging the amp in and, risking high voltage and shock and all that. And then I can test it with my low voltage power supply and make sure the keying circuit is working and keying. And also I'm going to go on a little bit on how to hook up the Nomad keying circuit. But first, I'll show you what I need, or what I use is this little power supply up here. That's a variable power supply. It can go from like 0 to 15, 16 volts, and it's current limited. The most this power supply it will put out is 2 amps, and you can dial that current meter down to like 0.3 amps or something like that. So if there's a short of something crazy going on, all this power supply will provide is at most 2 amps with it dialed up. And if it has a short, it'll cut out. So it's not gonna send 50 100 amps into my circuit and burn the circuit up. So I like that little variable power supply, current limited, and then it's got the LED output. It's set at 14 volts right now. Mind you, most CB preamps, not preamps, keying circuits run at about 16 volts, at least the base ones. They usually take it off the filament, which is either 6 volts or 12, and then they rectify it. On the 6 volts, they usually use a voltage doubler circuit. So you double the 6, and then when you change AC to DC, you multiply it by 1.4. So whatever 12 is times 1.4, it'll give you somewhere around 16, 17 volts. You can do the math if you want to. So anyway, I got that at 14 volts going into the where normally the power supply is. This is the filter cap for the keying circuit. So I just got the power supply coming in right here straight to the cap. And also this design of this Dynamite 150 is a little weird anyway, so that was just a good place to connect to, because all I'm going to is ground, and that's the negative side of that cap is ground, and the positive side is the output side of my 16 volts or whatever it is to run the keying circuit of this. So I just put it there. And again, with all the components on this board, this amp's a little weird because it goes out, the low voltage comes out of the board, and it goes into the transmit standby switch, and then it goes back into the board for the keying circuit. That's why you see all these little wires that this amp has. It uses a lot because of the design of the thing. It also goes for the AM SSB switch. It has a wire coming out the board again, and then going into the it's marked AM there. AM is SSB at the bottom switch, and then it goes back into the board. So it uses 2 wires to activate the SSB cap delay. Most amps use 1 wire, where they have the switch here on the other side of the cap, and it breaks the ground over here. And so you only need 1 wire going out, and then the switch is grounded. If you had moved the switch from the hot side over here where you got to go back in, over here to the ground side. I don't know why well, they didn't need to do that, but anyway, Transil's a little weird. I keep saying that. So anyway, I got it hooked up, got the transmit, which is the standby switch on, and it's on AM, and you can see it keying up the relay as I key the mic, right? Trying to get the mic in the picture. Everything working good. Oh, by the way, I had to hook the coax coming from my radio into this board too, because you don't have RF coming in. It's not going to key up, right? So I had to run the coax coming into it too. You can see the coax line over there. So coax in, power supply, in, and that's working good on AM. And Tram Doctor's getting old. I made a little mistake evidently on SSB. We put the SSB switch down now. Well, before we do that, let's do the transmit standby switch. There it is in standby. Not keying down. Put it back up to transmit. Relay keying down. Okay. Now we're going to do the SSB switch. And we're going to key it down. Then we're going to unkey. It stays keyed for about 20 seconds or so, right? What has happened is it had an old weird cap that the markings were wore off for the SSB cap, which in the schematic I made right there. And nearest I could figure, I thought that SSB cap was a 20 UF. So I put in a 20 UF because that was my best guess with the old cap. Yeah, that relay is unkeyed now, but anyway, key it down again and it's still keyed up. Still keyed up. It takes about 15-20 seconds for that thing to unkey because I couldn't tell what value that cap was. I guesstimated 20 and it's way too long. That's what happens there at unkeyed. That's what happens when you put in too big of a value of a SSB delay cap. The delay is way too long. You want about 1 second. And what that does is during SSB, when you pause your speech, there is no RF coming from the radio into the amp. So if you didn't have a delay, the relay would unkey every time you delayed in speech. So it'd be keying up, unkeying, keying up, unkeying, as you talk. So on SSB, most CB amps just put a delay on the relay, but the delay is only supposed to be about 1 second. If you make it longer, like this one is accidentally way too long. It's going to take 15 seconds before my receive comes back in if I'm trying to have a QSO, and I have my ears back, so you don't want that. If you make it too short, it's going to kick the relay out as you're talking. If you pause in speech like I just did then, it's going to unkey on all those pauses. If the delay is too short, if the delay is too long, again, it's going to hang up that relay for several seconds, and that's going to be aggravating too. By the way, with Black Cat, most Black Cat amps, they didn't have a SSB switch. They used a pretty short delay, which was a little bit long in the 2 for AM. It would hang up for maybe half a second, 3/4 of a second, which ain't the greatest for AM. But again, it would work on SSB if you don't pause. It wasn't it was like a compromise. It wasn't the greatest for AM, wasn't the greatest for SSB either. So it's, they tried to find a happy medium with that. But again, this one, most amps that have a SSB switch, delay is going to be 1 to 2 seconds, something like that. Neither fast nor slow. So anyway, this is how I safely test the keying circuit. So my keying circuit's good, relay's not sticking. And by the way, people say, hey, my relay is sticking, when I unkey. like it's doing now because I have that bad cap in there. Usually when it sticks, it's not the relay. It's the power going into the relay, something stick it. Like in this case, the cap is too big, so it's holding that ground on there too long. But in other cases, you're getting a harmonic, from the amplifier, and that harmonic is feeding back into the keying circuit, and it's hanging that relay up. Or there's a harmonic or something with your drive coming in, and it's causing some kind of feedback, and it's hanging that circuit up. Or one of your components that key the relay, usually a keying transistor, is leaking, and it's hanging that relay up. Normally it is not the relay. It's very, very rare when it's the relay. One way to find that out for sure, if you actually think your relay is sticking, unpower your amp. So I'm going to key that one up and let it hang, and I'm going to turn that delay off. As soon as I turn that delay off, it unkeys. Same thing, if you got the amp plugged in, your relay is sticking, unplug the amp, while that relay's stuck, and look at the relay. As soon as you unplug it, if that amp unkeys, it's not the relay, because the relay would have stayed stuck if the actual context of the relay sticking. If it stays stuck with no power and after all that, then okay, it's the relay. But I would say it's less than 1% when that happens that it's actually the relay contact sticking. They can arc together and stick and be sticky, or I've seen one or two with the weak spring and it didn't want to pull them back all the way. But 99.5 out of 100, it is not the actual relay. It's the components going to it leaking or something, or you're getting a harmonic and you're getting feedback, and it's keeping that circuit activated. And then last, I'm going to try to show up how to hook up a Nomad keying circuit. That's a little Nomad keying circuit he sells into an amp. Mind you, if you're going to use the Nomad keying circuit, it won't work on tube keying circuits. The voltages are high on tube keying circuits, including the relay, will run on 100 volts, 120 volts on a tube keying circuit. And this is low voltage only. And a few CB amps, even using transistor keying circuits, they use weird voltages. I know some DNAs, the early ones, they use tubes, so this wouldn't work. And then some of the later ones, after the tubes, they use negative voltage to key the relay. So this won't work on negative voltage. So, know your voltage. But again, I would say 95% of CB amps use, 13, 16, 18 volts DC. And this keying circuit work on all of those normal 13 to 18 volts or something like that. It'll work on all of those. So know your amp. I know like Palomar, PAL, Varmint, just most CB amps, Transel, they use normal 13, 16 volts. So on Black Hat, for most of them, even though early Black Hats used tubes, later Black Hats, they used transistors, but they did change stuff around a lot on Black Hat. So yours might not match, a schematic. But as long as you got a low voltage relay and it's positive, you can use the Nomad keying circuit. And the Nomad keying circuit basically got 4 inputs, or 4 connections. It's got in the upper left. Okay, in is the RF coming in from your SO239 plug. On this schematic, my chicken scratch, I got RF in there. That's where you would plug your coax in. And then on the other side of this, on the schematic, it goes to this little 10 picofarad sniffer cap and into the circuits to change that to DC. But since you're replacing, all the keying circuit with the Nomad, you would run a wire from the end of your SO239 to the end of the Nomad relay. Okay. Then where's the out? The out of this is actually what keys the relay. It grounds the relay. And over here, this is my schematic of the relay. Standard relay works like this. You got your DC voltage from the power supply coming in, just like on, my example here. I got it hooked to my power supply right now, but in normal operation, you got your DC from your power supply coming in, usually about 16 volts. It's going to go through the transmit or standby switch, standby operate, whatever they want to call it. And when the standby operate switch is on, it's going to send voltage to the key-in relay right there. So it's going to have that voltage on it. And then on the output side of the relay, that's the input voltage coming in. Output side is kind of upside down, but that made my schematic easier to draw. But on the output side, which I got in green, that's what's being grounded by the key-in circuit. And this one here, this transistor here, is actually what grounds it. In green, it's coming from the relay, and over here in black is the ground. That's the symbol for ground. It's got like a surge resistor right there that kind of helps this key-in transistor with surges. That's the thing for that resistor. And then this is the input or the base going into this transistor. So when it sniffs, some RF coming in, it's going to put a little bit of voltage on the base, and that's going to tell that transistor to turn on or act like a switch. So that transistor is going to connect the output side of that relay basically through here to ground. So it's going to ground that relay when it keys up. So anyway, going back to the Nomad, it's got all those circuits on the board. So you just hook the out to that output side of the relay. You need to figure out which is the output side though. But basically, if you look at the input side, it usually goes to the transmit, most of them don't call it the transmit switch. They call it operate standby switch. If you follow your wires to that, that will be the input side of the relay. And over here will be the output side of the relay in green. And then again, it grounds it when it sniffs that RF coming in through there. Other thing on the Nomad relay circuit is ground. But if you ground it right here and you mount this circuit board on this tab using this transistor here, that is also ground. So long as you connect it to a good bare metal, good grounded place on your amp when you install this board, I do on mine when I install it, it will be grounded right here, and hence actually you can see it, that center pin goes straight across into ground over here. So if you ground it there, with that mounting thing, you don't need to add another wire to ground it there. This thing is very low current. All it does is key the relay. You don't need to like run massive wiring and double wires for ground and all that in this case, So I ground mine through there. If you don't ground it or you mount it somewhere else and it's not grounded, then you will need to run a wire from ground to any place on the chassis that's a good ground. It's not RF going through there. You don't have to make it short and, heavy wires and all that in this case. All you're doing is keying the relay. And last is the SSB delay cap. This is the SSB delay cap used in the Nomad keying circuit. And all you're going to do is, if you're going to use SSB, not all amps do, CB amps do, you're going to send that out to a switch that grounds that point when you have the switch on. Transil's a little weird. Like I say, most of them just run this on the other side, that would be the cap that's in the transl circuit. And most people put that switch over here, break this side. Transls does not. So if I wanted to put this SSB in the transl, I would have to ground this side of the switch and run a wire from the SSB from here to right there. But on a normal amp like Pals, Palomars, Varmints, and most others, it's already going to be over here. It's going to ground that leg of the cap already. So all you would do is disconnect the non-ground wire from the AM SSB switch and run the wire to the SSB of that cap. And when you turn the switch on, it's going to ground that cap. So anyway, I got a little bit more long-winded than I wanted to, but that's basically it for a keying circuit. You got, DC coming in from the relay. Output side of the relay is grounded when it sniffs that RF coming in. They all use a transistor. It doesn't have to be this one, but it works a similar way. When it has our little bit of voltage coming in, it tells the switch A, activate, and the switch connects that to that. It's connecting your, voltage coming in over here to ground, so it's going to ground the relay. The relay's going to key. Most things that go wrong in these keying circuits are the transistor themselves, no matter what they are. This is a 2N 3053. Some use 2N 22As. Some use 2N 3906. Some use 2N 3904. But whatever they use, a lot of times people overdrive them. And they have more RF coming in. Where are you? Too many watts coming in, through these circuit. And then they hit the keying transistor, too many volts, too many watts. And it kills the transistor or makes it leak. And then it's hanging up the relay or doesn't want to key all the time. All kind of bad stuff. It's usually the keying transistor. What also can go, they usually have a diode in there. Sometimes it's in series, and this one is going to ground. But also, you run too much voltage in there, you'll kill that little signal diode there. A lot of times you're shorted out, and then your RF coming in won't reach the keying circuit, so it won't key. So check your diodes. You can do that with a meter if you know how to check your diodes. Usually it doesn't blow the resistors. And if it does, they're usually black or burnt or something, and you can actually tell it. But look up your color code and check your resistors with a meter. You can do that. But normally, keying circuit don't key. It's usually the keying transistor, and then check your diodes. So I'm gonna have a couple diodes in there. Check your diodes. It's usually that. I've seen some people really overdrive them, and I've seen that little sniffing capacitor there, a little small cap, usually 5 or 10 picofarads, very small. They put so many volts and watts trying to overdrive something, more watts, that they kill that. I've seen it, but not very often. Usually diode, keying transistor, and all else fails. If it's a normal low voltage, I just go ahead and put in the Nomad keying circuit. Solves all that kind of stuff. And the Nomad, if you get one, it comes with 2 resistors. And actually, those resistors go between the N and that SL239. I forgot to mention that. Don't run a direct wire. Run it through the resistors, one or the other. And these are made for how much drive you're going to use in the amp. If you're going to use low drive, I think this one was 1 to 10 watts, I think. Use this one. Or I did the opposite. 1 to 10 watts, I think. Use this one. The red 2.2K. And if you're going to run like 10 to 30 watts or something like that. I think that's the most it take. Use this one with the yellow, violet, red, because that drops down the voltage coming in, so you can hit it a little bit harder, but still don't overdrive it. You're gonna kill them. By the way, I said most of them use 2 diodes. That's the 2 diodes right here in between that resistor and capacitor. And most amps use a small keying transistor like that, and Nomad uses this big transistors here, probably about 5 times the power that a regular one would take, plus it's mounted directly to the chassis, so to take more heat, to take more abuse. So it should last, 10 times longer and take a lot more abuse than the standard CB keying circuit. So anyway, that's my thoughts on this one. Hey, Nomad looks at my stuff sometime. If I made any mistakes commentating, let me know. This is all off of my head. I don't go by a script. So that's it for this one. Bye.